Welcome! Do you know what redundancy topology is and its benefits? Redundancy technology enhances the safety and reliability of collaborative robots. The normal controller without redundancy can enter an error state if a slave encounters an issue. On the other hand, the controller with redundancy features two network interface cards, also known as NICs, ensuring backup in case of failure. This redundancy prevents accidents and maintains uninterrupted operations. By incorporating redundancy topology, systems can continue running smoothly even in the presence of failures. Let's look at this picture. In the normal controller setup, you can see that there is one NIC, and the connection from slave 0 to slave 1 is broken. As a result, slave 1 and slave 2 will not work due to the interrupted connection. In the example below, the controller has two NICs, enabling it to directly connect to slave 2. This redundancy feature ensures that even if there is a break in the connection between slave 0 and slave 1 and slave 2 can still operate smoothly. This image here is a screw fastening application field from NexCOBOT. In this image, you can observe various hardware examples where redundancy topology is used. The central piece of equipment is the GMC 110F motion controller, which serves as the main control unit. On the side that utilizes redundancy topology, you'll find the EtherCAT interface. This interface connects and coordinates other components such as the servo drives and the Neo 1812. These components form a redundant system that ensures enhanced safety and uninterrupted operation. Now let's dive into the demonstration and see how redundancy works. Let's focus on the screen as the pencil points around. When slave 10 is unplugged from slave 11, you'll notice that all the other slaves continue working, even though this line is broken. Once it's plugged back in, both the EtherCAT frames sent by the primary and redundancy ports resume normal operation. Now let's unplug slave 5 from slave 4. On the screen, you can see the EtherCAT frames sent by the primary port passing through slaves 1, 2, 3, and 4, while the EtherCAT frames sent by the redundancy port runs through slaves 5, 6, 7, 8, 9, 10, and 11. This ensures that both motors keep running smoothly and all slaves continue working. As you observe, when it's plugged back in, everything returns to normal. Unplugging and plugging slaves does not affect the system's functionality. Next, you will see an additional device added. On the screen, you'll notice a new box labeled Additional to represent this external device. This demonstrates that even when someone adds a non-system device, the motor continues to work. After watching this video, I hope you have a better understanding of redundancy topology. Thank you for watching.